We're ready to continue on with a really interesting topic of industrialization of construction. How are the challenges? How to address them? What it even is? I'm just going to set the context, and then we're going to turn it over to some experts in the field who flesh out this theme for us. We're going to hear some practical applications, and we're going to be a little bit provocative. So, last year, the Construction User Roundtable put it out an article about, is construction ever going to get with it? Are we ever going to have modern production in construction? But that, kind of begs the question, well, what the heck is modern production? Is it the movement of work off-site? Is it either moving it near or far? Is it standardization of designs? And what does it really mean for construction? Is it modularization? And by construction, I mean everything, the whole process of designing and building capital projects. And is it modularization? It's kind of the rage right now, thinking, if we modularize, we move it to a more controlled place to fabricate things together. We can avoid a lot of pitfalls, and we call that modern construction. Or is it, I call them declared factories. You see them popping up all over the place. I have a well factory. I have an offshore platform factory. I have you name it. I have an onshore separation factory. And is that what it means for construction? Or is those just really a replication of standard designs? So when I started doing some deep thinking about our project system, and I wanted to see and I wanted to understand what others were doing, I met with a whole number of companies outside the energy sector about what they do, how they did it, especially how they did product design. Met with companies like Apple, IBM, and as you can see, met with the Ford Motor Company. This was probably the most impactful of all the visits we had. So what in the world could Ford and Chevron have in common? And we found to start with that they wanted to understand how we make big bets in the energy sector, how we make those big decisions. And we wanted to understand how they did product design, how they did or product development, and how they did manufacturing. So as we sat down and talked, we found, man, we have a lot in common. We make big financial bets, both companies. You have to make a decision and then live with it for a long time with over many, in their case, millions of vehicles, in our case, a major investment. We're both highly regulated, extremely competitive. We have to all spend a lot of money to create new products, and it's very supplier intensive. We're not in this alone. So got to go to Dearborn, and it was really quite amazing to see what modern production really looks like. Everything from soup to nuts, everything from a screw design all the way to how they do quality checks with the F-150s coming off the production line. It was really quite impressive. And I just came back with a treasure trove of insights and observations about what we saw. I'm going to just talk about those for a few minutes before I turn it over. So first off, we started talking about how they do product design, and they started talking about their basis of design and the BOP. So what the heck is a BOP? I said, well, it's our basis of process. I said, okay, what the heck is a basis of process? Never heard that term before. And they said, well, that's how we're going to make the vehicle. So in their system, they have a basis of design like we have. It's the technical basis for what some facility we're going to have. But they put alongside it with equal weight how they're going to make that vehicle. And there's tension between the two, but they work those two through the whole life cycle of that project. Basis of process. That's how it will be done. Totally missing from our industry. And then that results in a complete bill of material. Literally every screw, every bolt, every rivet is accounted for in the design from point A to point B. None of that. Everything is designed completely. What a difference. They design to a cost. They have a really good cost structure. They understand what it costs to make things, and they set a cost target for a particular vehicle and satisfy the customer demand that they envision, and they design to that cost. And everybody is focused on it. Again, There's a lot of tension there between the basis of design and the BOP, but everybody's designing to that, and they're designing the manufacturing process in parallel to get to that cost point. They reuse standards. What you see and what the uniqueness is. But behind that, like if you got a compressor, you have three to choose from: a big one, a middle one, and a little one. And they expect you to reuse that design. They reuse as much of the things behind the scene, under the hood, under the frame that you can't see, you never touch, as possible. And that allows huge efficiencies in their system. They even have corporate metrics on design, reuse, and standards. Another huge difference is they do their own engineering. They probably have something like 80% of the own engineering, and they'd have about 100% if they could. Some of the things are proprietary, or they've got supplier engineered parts. So they gauged about 80% of their work was engineered. Huge difference. Full control of the engineering that goes along with their vehicles. Integrated suppliers, holy moly, they do something really special that I'd never seen in my life. They have a very good handle on the should cost. So the cost is really a minor deal. The commercial agreement between the two parties is very simple. It's not complicated with liquidated damages and complex incentives and all that stuff that we've gravitated to in the energy sector for sure. So it's very simple. But what's important is the way they've integrated the design of what the suppliers do into the overall design of the vehicle. So it's a fully integrated approach, fully integrated production, part of the production system. Ford has some 800 people sitting in the suppliers' offices around the world, ensuring this close coordination, ensuring this close work, and really making the supplier a part of the Ford family, if you will. And they really take it seriously. One supplier has a problem, other suppliers step in to help that supplier. They all win together. It's a surprising or an amazingly collaborative environment and cooperative environment, not commercially driven. They have one digital platform. Of course, they have hundreds of programs they use to do particular things, but everything is integrated into one digital model, one digital platform. Everybody has one source of truth, whether that's themselves or their suppliers. Everybody working together. I mean, this is starting to blow my mind at this point to see what they're doing versus, we look like cavemen compared to this. That digital platform even is connected to the ability to completely virtually build a vehicle. So they simulate the fabrication or assembly of their vehicles using their BOP and make sure they work out the kinks on how do they build it in advance. They even crash test a car. I said, wow, you crash test. How do you do that? How we wrote a program to do that? Because it's expensive to crash test cars. And they simulate maintenance so that later on people can actually maintain and get to the bowl plug for the oil and what, all the things that a mechanic has to do later on. Total virtuals. They have a really good handle on how they're going to make it, how this vehicle is going to perform and be maintained over its life. Then they build one. They build a prototype, and they say, okay, they learn a lot from that on actually testing out the things that they've planned in the digital environment. Then they make about 40 vehicles, and they take them for a test drive. They work out a few more minor details, and then they go into mass production, creating thousands or millions of a vehicle. So we spent a good share of time with the people that do product design, and that was kind of what I just ran through really quickly. I got to say that it was really quite amazing whether we talked with finance people, the head of their engineering group, the head of their supply group, whoever it was. They all understood vehicles. They're all motorheads. They all understood the business of making a vehicle that satisfied a customer and would give them a return on investment. It was really, really quite amazing. It wasn't a very siloed organization at all. And then we got to see the line, went out to the F-150 line, and that again was just totally eye-opening. I had no idea that every vehicle coming down that line is unique. Every one is made to order. And they're not like we make a batch of this and we make a batch of red ones with these certain features and we make a batch of white ones with these features. No, every vehicle coming down that line is unique, made to order, which means when the worker turns around and picks up the next part for that vehicle, it's got to be the right part that matches that order, whether it's the red or the blue or the leather seat or the vinyl seat or whatever it is. It's got to be the right part for that particular order for that vehicle. And it's got to be reliable. Every time they turn around, 100% of the time, it's got to be the right part. And that which ties to the inventory management. And it just, I was on overload at this point because it was so different than what we did in Chevron. They deliver roughly 1.6 million parts to that factory floor every 24 hours. Stop and think about that. 1.6 million of the right parts, of the right models to make those unique vehicles so that they can produce one truck every minute coming off of that line. Now, I had to think, if that was Chevron, we'd have 2 years of parts sitting out in the warehouse. They do it with 5 days, and they think that can be improved. 5 days of inventory, and this stuff's sourced from all over the globe. It's not like everybody's just down the street in Dearborn. Stop and think about that for a minute. I mean, these people live in a world that is so different than the world I was living on, and it was almost overwhelming to figure out where to start. And again, everybody is focused on factory throughput, one F-150 every minute that met quality requirements, quality expectations, and that's the flow. It was interesting that we were standing around watching the guy, the people work on the line, and some of them were checking, they're doing some texting, talking on the cell phone, looking at websites, waiting on their turn for the next vehicle. Productivity was, I wouldn't say low, it was just relaxed. And again, if that was us, we'd be whipping those people. You got to find something else for them to do. Can't they be doing something else at the same time? Look at all that dead time. No, none of that mattered. It was all throughput, flow. If that meant people were standing around waiting on the next thing, fine, because they weren't going to build up unnecessary whip in their system. And, the other thing that was just obvious as we talked to everybody as we went through this is how fluid they were in operation science and the concepts that go with it. I mean, they live and breathe whip. They live and breathe tack time. They just live and breathe all that stuff. It's not like a debate or a conversation about how did you apply this? How did you apply that? They're just doing it. And instead they're building more and more efficient. They thought they were kind of average. They looked at Toyota as the best of the best in how they do this. And they're striving for continual improvement and using technology and improving their methods. It was really, really quite a special thing. And we brought that home and started saying, okay, what do we do? Taking all this at once is just trying to bite the elephant at one time. And for me, it just kind of got focused on, well, let's come back to the beginning, the basis of process. We need to be very focused. We start being very focused on sorting out how we're going to do something and holding that in equal weight to the basis of design. We need to design to a cost, design, reuse, and standards. We need to narrow the field on how many different engineering companies we work with so that we can work out issues with them. We need to get away from these complicated commercial arrangements and instead have simple arrangements that allow us to work together with our engineering companies and suppliers. We need one digital platform, and that's just the beginning. So those are kind of my takeaways. It was really insightful, and I think now we're gonna have the opportunity to hear from an expert in the field of how to take and taking a deep dive on concurrent engineering. So let me move on and introduce our next speaker.